friends, I am Vaibhav Srivastava from Vaibhav E-Learning Academy. Today we are going to continue our topic Newton's laws of motion, and this is our part number 3. In today's video we will be learning about impulse. What is impulse? In the previous video we have learnt about the Newton's second law of motion, in which we discussed about F is equals to dp by dt. We derived the equation that F is equals to ma equation, we derived it, and then we solved many numericals on that topic. In today's video about impulse, we will see what is impulse, what are the examples of impulse, and what is impulse momentum theorem. And we will discuss about many numericals, many problems regarding impulse. So I hope you will enjoy this video. So let us start with the topic of impulse. So why did this impulse topic come? In Newton's second law of motion, where F is equals to ma, we were using the equation F is equals to ma. We were using the equation F is equals to dp by dt. So here we are changing the momentum, we are changing the time, we are changing the mass, and we are changing the acceleration. But in all these formulas, one thing was constant: force. The force was kept constant in all these formula. But what if in any case the force is variable? What if you have to change the force in between? Then what will you do? For that you have the impulse. Now, till now we were discussing about the Newton's laws of motion where the force was constant. But what if the force is not constant and the force is varying? So that impulse is the term which we use. Now first let me write the definition of impulse. What is impulse? Large amount of force acts on a small or in a small amount of time. Small amount of time is called impulsive force. Impulsive force or impulse. So, if a large amount of force acts in a small amount of time, suddenly a lot of force you are applying at a very small amount of time, at that time the force which is applied is called impulsive force or impulse. So this was the basic definition. Now this is about the impulse. So at a particular instant, like in a millisecond or in a second or in a millisecond or in 2 seconds, 1 second time, if you are applying a lot of effort or lot of force on that at small amount of time, that type of force is called the impulse. Now one thing about impulse is it does not remain constant. The force does not remain constant. That is why we are using the impulse when the force is not constant. The force is variable. So here, how does the force vary? First thing, the force is at 0, then increases to maximum, and then comes back to 0. Back to 0. So the force is at 0, then increases to the maximum, and then comes back to the 0. What does it mean? The same definition of impulse. The force you are applying, that at a particular time, at the starting the force is 0. Then when that time comes, you suddenly apply a lot of force, and then again you come back to 0. This is how impulse works. So the large amount of force in a small amount of time, this thing is justified over here. First it is 0, then maximum, and then back. 0, maximum, and then back to 0. These are the three main definitions. This is the definition about impulse. What basically an impulse is. Now this is the basic idea or basic definition about impulse. Now what is impulse? Formula. what quantity is it? Vector quantity, scalar quantity, what are the units? We'll discuss about these now. Before moving on to any of these, we are going to discuss this in a graph, impulse in a graph. So one main point is area under force time graph gives impulse. The area under force time graph gives us impulse. How will a particular or how will a common impulse graph look like? This is force, this is time. It starts from 0 and comes back to 0, and this area will be the impulse. Okay, here the third point is specified. It starts from 0, suddenly reach to the maximum, and then comes back to 0, and here time t1, here time t2. This is the one more important term, that is the area under force time graph gives impulse. Now using this another definition, we will try to derive the formula for impulse. So let us see. First, this graph. Force in the y-axis and time in the x-axis. This is the impulse. Now, let us take this is time t1, this is time t2. Okay. Now, we have to find the area under this graph. Usually, this is the force and this is the time, and the force is something like this. Then you can find area easily, half into base into height. You can find it easily. Or if it is a square or rectangle, side into side, length into breadth, etc. But here, what if there is none of these shapes available? Then what will you do? This is that case. So, in these type of examples, what you have to use is use integration. How will you use integration? Let me tell you. So this is the impulse which is under the force time graph. Now, for getting impulse, so basic let me give you the formula. Impulse is equals to force into time. Okay. So here you are seeing this graph of force. If you see the force, there is no force which is common. So for example, if it is a square, it is like this. Okay, force and time. So here you can see the force is constant, but here the force is not constant. So you have to take one area where the force is constant. Here there is no area where the force is constant. Force constant in the sense the time is increasing but the force is not increasing. Like at the tip, if you see, the time increased, very little time. Let's take dt, very small change in time. For that the force is constant. So what we do is, we take one small strip, one very thin strip we take. Why are we taking a very thin strip? Let me tell you. So if you take this thin strip outside, it is like this. Okay. From here to here, let us assume this is dt. Okay. Why dt? dt is the small change in time, and this one is the force F. Now, this strip area, if you find the area of this stripe, then you will get the impulse of this strip at time dt. You will get the impulse of this strip at dt time. So, impulse is force into time. If you take this one strip outside, you will get the impulse of this small strip at time dt. Similarly, take one more strip, for example, at over here. Like this, if you take a thin strip outside, this if you take out, this will again be equal to F, this will be another dt. So here, what you are getting, impulse is equals to F dt. Why F dt? Because area is equals to length into breadth. What is the length here? Length is F. What is the breadth here? dt. So what is the area? Area under force time graph is called impulse. So impulse is equals to force into dt. Now this f dt and this impulse will be actually di. Small change in impulse, because we are not taking full, right? We are taking small impulse. So small change in impulse di is equals to f dt. Now like this, if you take so many strips from here, if you take one strip like this, one strip like this from over here, like this, everywhere, full graph, if you take strips and take it outside, and this f dt values, if you add them, you will get the total area, right? From here you are taking one small strip, from here you are taking one small strip, from here, like infinite amount of small strips if you take, if you add them together, the area, if you add the area together, then you will find the total area, right? So what we have to do here is integrate this on both sides. Okay? Why are we integrating it? Because we have to remove this d from here. To remove d, we have to integrate it. If you integrate it on both sides, impulse is equals to, because integration d will come out. Now dt when we are taking from time t1 to t2, so t1 to t2, so f into dt from t2 to t1, so f dt from t1 to t2, and this is the formula for impulse. So impulse is equals to integral of f dt from t1 to t2. This is the formula for impulse. Let me explain once again. So this is the force and time graph. For one particular scenario, this is the force time graph. So at small amount, at some time from t1 to t2, F force is acting from t1 to t2. Like this the graph is. Area under this graph is impulse. This is what we learned just a few minutes ago. So here, for finding the area, how will you find area of a curve? It is not even a circle, so you can't find area. It is just a random figure. How will you find area of this? So here you have to see this area, for example, if you take it if you maximize that minimum part, something like this if you are seeing. So if you take a very small portion, you will see this curve is almost equal to a straight line. This curve is almost equal to a straight line. Over here, if you take a very small portion, that curve will be equal to a straight line. And why we are taking the curve equal to a straight line? Because that will give us a rectangle, and we can find the rectangle area easily. So we are taking one strip that is from very small time, dt. So from dt, we are taking one strip, we are bringing it outside. The breadth of that strip is dt, and the length of the strip is f. Area under the graph is area under force time graph is impulse. So impulse is equals to area. Area is f dt. So area is equals to f dt. Impulse is equals to f dt. But here that impulse is very small. It is di. So if you want to remove that d, you have to integrate on both sides. Integration from here and here, d will come out because there is no limit over here. But f dt, we have the limit from t1 to t2, and di is equals to I. So impulse is equals to f dt from t1 to t2, and this is the formula for impulse. So impulse is equals to force into time. This is also correct formula. But usually this is in the case when the time t is equal to 0. Let me explain you. From time t1 to t2, right? When will you get this formula? If the time t1 is equals to 0. If they say the body starts at t is equals to 0 to t is equals to 3. They will give some question. We will do some questions later on in this video. In that, it will show us the impulse. The impulse t is equal to 0 to t is equal to some particular time. So at that time, t1 will be 0. Then t2 will become the t. Then this will become I is equals to ft. This is over here. So this is the main formula for impulse. Impulse is equals to f into dt. Now, as I was talking about in the starting, there will be one more formula that is called as impulse momentum relation. Before moving on to that, let us discuss some units and the quantities like vector quantity or scalar quantity. So impulse, it is a vector quantity. Vector quantity. If it is a vector quantity, it has both magnitude and direction. The direction of a vector is the direction of the force. So wherever the force is being applied, the impulse is also in the same direction of the force. So it is a vector quantity. The unit is kg meter per second. SI unit is equals to kg meter per second. And CGS unit is equals to gram centimeter per second. Now one more interesting thing. When we are talking about force, we are talking about the effect of the force. We don't talk about how much force is applied. In impulse case, most usually, we don't talk about the force. We talk about the effect of the force. That if you are applying this much amount of force, what is the effect on it? What will be the result? So that we are talking about. So impulse is a vector quantity. The SI unit is kg meter per second. CGS unit is gram centimeter per second. This was basic about the impulse. Now let us move on to another relation that is called impulse momentum relation. So let us see. First one, from Newton's second law. From second law, F is equals to dp by dt. We know that. F is equals to dp by dt. Now, if this dt you take and keep it in the left hand side, then you will get f dt is equals to dp. F dt is equals to dp. And what is f dt? F dt is the impulse. So, if the change is big, what we write? We write it as delta. But this is a small case. In most of the books it is written as delta also, but here we are taking dp. So what we have to do is integrate on both sides. Okay, so f dt is equals to dp. Once again, f dt is equals to dp. So we integrate on both the side. We get integral of f dt from t1 to t2 is equals to integral of dp from p1 to p2. Okay, because it is dp, so from initial momentum p1 to final momentum p2. This is from initial time t1 to final time t2. This we will get. Now what is f dt from t1 to t2? This is impulse. So impulse is equals to dp from p2 to p1. Then it is obviously p from p1 to p2. So impulse is equals to p2 minus p1. Or you can say impulse is equals to delta p. Impulse is equals to p2 minus p1, or impulse is equals to delta p. This impulse is equals to p2 minus p1. This is called impulse momentum theorem. Impulse momentum theorem. About this momentum, specifically linear momentum, we will talk about in the Newton's third law video. So this is the impulse momentum theorem, which says that I is equals to P2, final momentum minus initial momentum. Let us see that again. From second law, we know that F is equals to dp by dt. If this dt you will take up, then you will get F dt is equals to dp. Now, you integrate them on both sides. So F dt from t1 to t2 is equals to dp from p1 to p2. This term is called impulse. Impulse is equals to p from p1 to p2. Limit is initial momentum to final momentum. Then you will get impulse is equals to p2 minus p1. This p2 minus p1 is called change in momentum. So impulse is equals to delta p. And one more thing, this delta p is equals to m into v2 minus v1. Okay, because momentum. So this is actually basic. I'll tell you more about it. This is the basic derivation. Now here impulse is equals to p2 minus p1. Impulse is equals to p2 is equals to mv2, because pressure momentum is equals to mass into volume, minus p1 is equals to mass into v1. Mass will be constant, right? So momentum varies, but mass is the constant. Volume, velocity varies, but the mass is the constant thing. So impulse is equals to mass into v2 minus v1. This is other form of the same equation. This and this are both are same. This is the impulse momentum theorem. So these were the basics about this impulse derivation, formula derivation. Now let us look more about these things. So So now let us look at some uses of impulse in our day-to-day life. So one of the major use of impulse is in hitting or in kicking, jumping, etc. Let me explain. How is it on hitting? If you are hitting, for example, cricket, so the ball, you are hitting the ball with the bat. So the bat, you are applying some force on, large amount of force in a small time. You are applying large force in a small time, so the ball flies away. Why? Because of impulse. When you are kicking a ball in football, you are applying large amount of force in a small period of time. Then also impulse comes in. When you are jumping, you are using a large amount of force in a small amount of time to push yourself upwards. There also you are using the use of impulse. Yeah, there also you are using impulse. So next, one more important term regarding impulse. We know that F is equals to dP by dt. This, how did this come? F dt is equals to dP. Okay, so F, this dt came over here, so dP by dt. So force is equals to dP by dt. This is one important term. From here we will say that force is inversely proportional to time. This is one very important term. Force is inversely proportional to time. Now, it means that if force is more, or else you can say if the time of impact is more, then the force is less. If the time of impact is less, then the force is more. This is one very important term in impulse. So let me explain how is this important and where do we use in real life. So when you are catching a ball, so what you do is you take the hand backwards. If a fielder is catching a ball or a bowler is catching a ball or whatever, the ball, when it comes towards him, he keeps his hand backwards. Why? If you pull your hand backwards, you are increasing the time of contact. If you increase the time of contact, then the force applied will be less. So if a ball is suddenly coming towards you, you catch it and pull your hand backside, so that you are decreasing the time. If you you are increasing the time. If you increase the time, then the force applied by the ball on your hand will be low. Then you won't get much damage. Similarly, another case, if you decrease the time. When a ball is coming towards a bat, in cricket, if the ball comes towards a bat, are we waiting for the ball to hit the bat? If this is the bat and the ball comes like this, the ball is coming, we are not waiting for the ball to hit the bat. We swing the bat in front, like we swing the bat forward. Why do we swing it forward? So that we reduce the time of contact. If we reduce the time of contact, the force applied by the bat to the ball will be more. So the acceleration will be more, thus the ball will fly away further. That is why when we are playing cricket, during batting, we keep the bat in front. We swing the bat in front. Why do we swing it in front? So that we decrease the time of contact. And force is inversely proportional to time. If you decrease the time, then the force applied will be more. That is the case where the relation F is inversely proportional to T will help us. And these type of questions may come in exam. A bowler catches a ball and pulls his hand backwards. Why? Then the option you have to say to increase the time of contact, thus decrease the force. This is the uses of this impulse. Now, regarding this, we have some of the examples also. This catching is an example of impulse. The hitting is an example of impulse. Then one more thing. If you fall on sand or water, that won't give you much damage. But if you fall on concrete floor, then it hurts more. Why? Because when you are jumping on a sand or on water, then the force which you are using, that is being used to remove the sand. See, the time of contact decreases. Till you reach the ground, your force will be completely dissolved in water, or your force will be completely used in removing the sand. Because if this is the ground, these are the sand particles, right? Till here, these are the sand particles. So till you reach the ground, most of your force is used in removing the sand to reach the bottom. That is why your time of contact increases and your force decreases. But if you fall on a concrete if you fall on a concrete floor, then the time of contact is less. You suddenly fall. When you fall on the floor. and if you fall on the floor, the force increases. You get more damage. But if you fall in sand or water, your force helps you in reducing your time helps you in reducing your force. How? Because that force is used to remove the sand or to remove the water, to displace the water. So that is how, or that is where we use impulse. Now these are the basic terms, basic definitions, basic things about all impulse. Now let us start moving on to the questions. We are going to solve a lot of numericals. So let us see. So now we have our first question over here. This is our graph and we have to find the impulse in this graph. So we all know that impulse is the area under force time graph. This is the force and this is the time. The area under this graph will be the impulse. So first we have one square and one rectangle. This is one very easy question. So we have a square and one rectangle. So first let us take the area of the square. So area of square is equals to minus 2. From here to here also it is 2, and from here to here it is minus 2. So it is actually not a square. You can take area, total area is equals to, this is 2 into minus 2 plus this area also. This is also one rectangle over here, and you have to find the area under that also. So the area under this rectangle is from 2 to 6, the difference is 4, and from 1 to 2 the difference is 1. From 0 to 1 the difference is 1, and from 2 to 6 the difference is 4. So 1 into 4. So 2 into minus 2 is minus 4, plus 1 into 4 is 4. Minus 4 plus 4 is equals to 0. Thus the impulse is equals to 0. This impulse is 0. This was our first question, very easy question. So what we did was we just found the area under the force time graph to find the impulse. Let us move on to the second question. So now we have our second question over here. A small sphere of mass 2 kg moving with a velocity u is equals to 4I cap minus 7j cap meter per second collides with a smooth wall and returns with v is equals to minus I cap plus 3j cap meter per second. Find the magnitude of impulse. So here we have to find the impulse magnitude. So first the 2 kg ball is moving with starting velocity this much, and then when it collides with the wall and comes back with this velocity. Now we have to find the impulse. Impulse is equals to force into time. Okay. Here we are not using that from time t1 to t2 or integration, because it is a small force. So force is equals to mass into acceleration. F is equals to ma into time. So impulse is equals to force into time. We are not using any integration over here because they have not given from time this is equal to this or that is equal to that. So force into time, that is the basic impulse which we are using. Force is equals to ma. So ma into time. Now acceleration is equals to, force is equals to mass into velocity. So mass into acceleration is mass into acceleration is equals to dv by dt, or you can say velocity by time into time. Okay. Here actually acceleration is change in velocity by time. So it is delta v by t because the change is large. Now here t and t can get cancelled. So impulse is equals to m delta v. This is one approach. Okay. This impulse is equals to m delta v. What is this? This is the impulse momentum theorem. Same thing, that impulse momentum theorem can be derived in either that way or this way. So both are same. So impulse is equals to mass into change in velocity. Now delta v is equals to, mass is already given 2 kg, so they are not caring about that now. Delta v is equals to v minus u. What is v over here? Minus I cap plus 3j cap minus u is 4I cap minus 7j cap. Okay. Now we have to find the delta V value. So it is, first we'll bring out the terms, minus I cap plus 3j cap. This minus and plus will become minus, so minus 4I cap. Minus into minus is plus, plus 7j cap. Okay. Minus I cap is equals to minus 5I cap. Minus 1 minus 4 is minus 5. And plus 3 plus 7 is equals to plus 10j cap. So delta V is equals to minus 5I cap plus 10j cap. This we found delta V. Now impulse is equals to mass into delta V. Impulse is equals to m delta V. Okay. We have to find the magnitude of impulse. This is important. Magnitude of impulse. So mass is given 2 kg. So 2 into delta V. Now let us find the magnitude of delta V first. So V bar under the magnitude will be equal to root 5 square plus 10 square. This we already know how to find the magnitude. In the vectors video we have discussed about it. So how will you find the magnitude of a vector? In under root you have to take the I cap whole square plus the j cap whole square. So here 5 square plus 10 square. So V bar under root 5 square is 25 plus 10 square is 100. So this you will get V bar mag is equals to under root 125. Okay. So magnitude of V bar is equals to, you can write this 125 as 25 times 5. 25 into 5. Okay. 5 5s are 25, balance 1, 5 to the 10, 11, 12. So balance 2. Actually 5 5 25, balance 2, 5 to the 10, 11, 12. So you'll get under root 125. Root of 25 is 5. So V bar magnitude is equals to 5 root 5. Okay. So this we need to find the magnitude of change in velocity. What is the magnitude of change in velocity? It is 5 root 5. And 2 5s are 10. So this is 10 root 5. Impulse is equals to 10 root 5 kg meter per second. So this is how we got the impulse. Let me explain once again if it is confusing. Impulse is equals to force into time, or else you can directly use the impulse momentum relationship, but here I derived it in another method. Time and time gets cancelled, so you get m delta V. Now delta V is the change in velocity. From u to v, what is the change? So v minus u, you will get the change in velocity. So the change in velocity is v minus u. V minus u you will get as minus 5 I cap plus 10 j cap. But you have to find the magnitude. So you have to find the magnitude of that velocity. Magnitude, we know how to find the magnitude of the vector. So we found the magnitude, and here this magnitude is equals to 5 root 5. So impulse is equals to mass into velocity magnitude. So 5 into 5 root 5, which is equals to 10 root 5 Newton per meter, kg meter per second. So this is the magnitude of impulse. This was our first question. So I hope you have understood this question. Let us move on to our question number 2. So now we have our question number 3 over here. An object of mass 3 kg is at rest. So this gives 1 point, that u is equals to 0. Now a force of F is equals to 6t square plus 2t j cap is applied on the object. Find the velocity of the object at t is equals to 3 seconds. So in this kind of question also, now here actually they have given force. This force is variable force. Till the last question it was constant, but here it is a variable force. So here the force is variable. You have to use the energy. You have to use the impulse momentum theorem over here. Now what is impulse momentum theorem? It means that impulse is equals to delta P. Okay. Impulse is integration of f dt from t1 to t2, and delta P is m into v minus u. This is the thing which we have to use in this question. Here they have given mass is equals to 3 kg. So given data, m is equals to 3 kg, u is equals to 0, f is equals to 6t square I cap plus 2t j cap, and time is equals to 3 seconds. So impulse is equals to f dt. So here integration of f is 6t square I cap plus 2t j cap from 0 to 3, because they are asking at 3 seconds. So we know integration. Here this is in the form of x to the power n. X to the power n integration dx is equals to n x to the power n plus 1 by n plus 1. This is the integration. So 6t square. So it is square. It will be equal to 6t cube by 3 I cap plus 2t square by 2 j cap. 2 cancel, 3 1s are 3. So whatever you do, you will get the answer to be integral of. So it will be here 2t cube I cap plus t square j cap. I'll explain this again how you got this. So it will be 6x into n to the power n plus 1, x to the power n plus 1. So 6t to the power 2 plus 1 is 3 by n plus 1 is 3. So 3 1s are 3 2s are. So 2 3 cube plus 2t. Here the power is 1. So 1 plus 1 will be 2 by 2. 2 cancel, you will get t square. So this is how you got the impulse. So here it is 2t square I cap plus t square j cap from 0 to 3. These are the limits which are given to us. So from till 3. So t value, this is the upper limit, this is the lower limit. This upper limit we have to substitute first and then subtract from the lower limit. Lower limit is 0, so 3. This will be 3t cube. Sorry, t cube. So 2 into 3 cube I cap plus 3 square j cap. 3 cube, this will be equal to 27. 27 2s are 54 I cap plus 9 j cap. So here what you will get, after applying all these things, you will get 54 I cap plus 9 j cap. This is the impulse. Now impulse value we got. Now impulse is equals to m into v minus u. Impulse is equals to 54 I cap plus 9 j cap. So 54 I cap plus 9 j cap is equals to mv. Now u value is, this u value will be equal to 0 because they are given the object is at rest. U is equals to 0, right? So this will be mv minus mu. This mu is equals to 0. So this value is equals to mv. Now 54 I cap plus 9 j cap is equals to mass is 3 kg. So 3 into v. This 3 you bring it over here. So 54 by 3 I cap plus 9 by 3 j cap is equals to v. Why it is separate? Because here addition is there. So 3 1s are 3 1 18. 18 I cap plus 3 j cap is equals to v. Thus we got our answer. We have to find the velocity. So actually what we did, let me explain it once again. So here object of mass is 3 kg at rest. So rest means u is equals to 0. So m into v minus u, this will be 0. So mv only. Force is given 6t square I cap plus 2t j cap. Integrate that and I and j will be separate because they have given it separately. Then after integration you get this value as impulse. If they ask you impulse, this is the impulse, and you can find the magnitude also if you want. But this is the impulse and velocity. So impulse is equals to delta p mv, okay, because u is equals to 0. So m into 0, anything into 0 is equal to 0. So impulse is equals to mv. M is 3. So this 3 will come to the left hand side as denominator because here it is multiplication, and after that you get the final velocity. So initially it was 0, you apply some force on it, and after 3 seconds the velocity is 18 I cap plus 3 j cap meter per second. This was our third question. So now let us move on to the next question. Let us see. So now we have our next question over here. A hammer of mass 1 kg strikes on the head of a nail with a velocity of 2 meter per second. It drives the nail 0.1 meter into a wooden block. Find the force applied by the hammer and time of impact. So here given data, mass m is equals to 1 kg with a velocity of 2 meter per second. V is equals to, so actually it is initial velocity, u is equals to 2 meter per second, and it drives the nail 0.01 meter. So displacement is equals to 0.01 meter and final velocity is 0. Because when you hit the hammer at the last, the velocity is 0. We have to find the force and we have to find the time of contact. This is the information which is given to us. So first let us find the force. Find the force. F is equals to ma. What we don't know? We don't know acceleration over here. So how will you find the acceleration? V square minus u square is equals to 2as. This would perfectly fit in this situation. V we know, u we know, a we don't know, s we know. So we can find acceleration value easily. V square, so 0 minus u square is 4. Is because it is 2 square, 4 is equals to 2 into acceleration into displacement is 0.01 meter, which I can write 1 into 10 to the power minus 2 meter. Because this is 0.01, so it is 10 to the power minus 2 meter. So instead of this, we can write directly into 10 to the power minus 2 meter. Now this minus 4, this 2 into acceleration, this 2 will come over here by 2 is equals to 10 to the power minus 2 into acceleration. 2 ones are 2 twos are. So minus 2 by 10 to the power minus 2 is equals to acceleration. This 10 to the power minus 2 comes in the numerator as 10 square. So minus 2 into 10 square is equals to acceleration. Minus 200 is equals to acceleration. What we have to find? We have to find the force, right? So here F is equals to ma. Mass is 1. So 1 into acceleration is 200, which is equals to 200 Newton. This is the part 1 of the question which we had to find. So this is equals to 200 Newton. So the force by the hammer. Second, we have to find the time of impact. For time of impact, we can use V is equals to U plus AT. We know V, which is 0. We know U. We know A now. We also know, so we don't know time. We have to find the time. So V is 0. 0 is equals to U is 2. Right? Plus acceleration is 200. So 200 into T. See here minus acceleration because we are applying it. See, this all depends upon the direction which we are doing. Here minus plus it won't matter much because here it is just F equal to m. Here we are just finding the magnitude of acceleration. We don't need to find the direction here. Only we have to find the magnitude here. So no one cares about plus and minus over here. This 2 will come over here. So minus 2 is equals to 200t. This 200 will come over here. So minus 2 by 200 is equals to t. 1 by 100. Or even if you want to take it, acceleration is equals to minus 200. You take this over here as minus 200. This will come down minus. Then also will get cancelled only. At the last, everything has to get cancelled. So 1 by 100 is equals to t. 0.01 second is equals to time. So hammer you are applying on a nail. So you are striking the hammer on a nail just for 0.01 second, and that time, see, at that small amount of time, a large amount of force you are applying. How much force? 200 Newton at in just 0.01 second, and it is making a displacement this way. So this is how we found force, and that is how we found the time. Let me explain once again. A hammer of mass m is equals to 1 kg strikes the head of the nail with a velocity 2 meter per second. U is 2, V is 0, because after striking we do not again strike it again. So drives the nail 0.01 meter, which is equals to 10 to the power minus 2 meter. We have to find the force and we have to find the time. So F is equals to ma. we used v square minus u square equal to 2as. We found the acceleration. That acceleration into mass, we got 200 Newton. This, if you appropriately write, it is minus 200 Newton. The force, the work is being done on the body. For time, we used v is equal to u plus at. The same minus 2, acceleration minus 200 will come over here, minus minus cancel. T is equal to 0.01 second. Now let us move on to the next question. Let us see. So now we have our next question over here. A cricket ball of mass 150 gram is moving with a velocity 12 meter per second and is hit by a bat so that ball is turned back with velocity 20 meter per second. The force acts for 0.01 second on the ball. Find the force. Here again we have to write the given data. Mass is equals to 0.15 kg. It is 150 gram. 150 gram into kilograms is equals to 0.15 kilograms. Velocity 12 meter per second. So u is equals to 12 meter per second and is hit by a bat so that it is turned back with the velocity 20 meter per second. Here you have to take the plus or minus sign importance you have to see over here. So here, if the ball is going like this, after hitting it is coming back like this. If here you are taking positive, then this is equals to negative. So when the ball is going towards the bat, you take it positive. You can assume anything, but when it is going towards the bat, you assume it is positive. That is coming from the bat, you can take it as negative. So V is equals to, so actually we have to find the force which is on 0.01 second. So the main thing will be happening when we are, the main observation will be when the ball goes away, not comes. So we can take this as positive. Negative. So how to choose which is positive, which is negative? You have to see where you will do the maximum observations. Wherever your observations are maximum, that you can take as positive and the other you can take as negative. Here when you are hitting the ball, then you will see the final velocity of the ball. Then the force will be acting in the direction of the final velocity. The time impact will also be in the time only becomes the final velocity. It changes the initial velocity into final velocity. So everything will be in the final velocity time. So you take that as positive. So here u is equals to minus 12 and v we are taking as 20 meter per second because it is given. Force acts for time is equals to 0.01 second. What is the force? This is, we have to find out the force. To ma. Okay, we have to find the impulse. Impulse is equals to force into time. If you find the force first, then you can multiply that with time. Mass is 0.15. Acceleration you can take v2 minus v1 by t. Here also you can use that impulse momentum theorem also. You can use any method. You can use this also. You can use that impulse momentum theorem also. Impulse is equals to change in momentum. But here why we are not using that, it is because they did not give any integral values or f is equals to 60 square dt. Like that they did not give here. So you can directly use this one. Much easier. 0.15 into. Now v2 we are taking it as final velocity. v1 we are taking it as initial velocity. So final velocity is 20 minus initial velocity is minus 12. 20 minus of minus 12 by time is equal to 0.01. We can take 10 to the power minus 2. Okay. So 0.15 into 20 minus of minus is equals to plus 32. 10 to the power minus 2 will come upside as 10 square. This 10 square and these decimal will get cancelled. Okay. So force is equals to 32 into 15. So 32 into 15. So force is equals to 480 Newton. So do you see? 480 newtons of force is being applied on the ball at 0.01 second. That is where we use impulse. Again it is see, they are given mass is equals to 0.15 kg or 150 gram. U is minus 12 meter per second. V is 20 meter per second. Why we are taking minus 12? From where we are doing most observations that we are taking positive and other negative, or else it is going as negative coming back as positive. So we use F is equals to ma. Mass is 0.15. Acceleration v minus u by t. The v is 20 minus of minus 12. So you will get force is equals to this 10 power minus 2 to come. So you will get force is equals to 480 Newton. Now let us move on to next question. So now we have our next question over here. A cricket ball of mass 250 gram collides with a bat with velocity 10 meter per second and returns with the same velocity. So u is equals to 10 meter per second, v is also equal to 10 meter per second. Here minus plus we have to see. Find the force exerted by the bat on the ball. This is our question. So here what they are given is mass m is equals to 250 gram, or we can say 0.25 kg. Okay, you know the conversion, right? 1 kg is equal to 1000 grams, so 250 that you can do, you will get 0.25 kg. Now u, they are given 10 meter per second, and v also it is 10 meter per second. Which one you have to take positive, which one you have to take negative? So usually in these kind of cases, when it is going to hit, you can take that as negative, and when it is coming back. So here cricket ball of mass, this collide with the bat, right? So if the ball is going to the bat, then you can take it as negative, going as negative and coming as positive, because the most of the observation is being done in the v side, so the final velocity side. So you take u is equals to minus 10 meter per second. Now we have to find the force exerted by the bat on the ball. Here one more term is missing. Actually here the time will be equal to 0.01 second. Yeah, so the time is equal to 0.01 second also. This one I missed it, sorry. So here time t is equals to 0.01 second. Now we have to find the force exerted by the bat on the ball. Again we can use F is equals to ma. Mass is 0.25. Acceleration is v minus u by t. Okay. Now here also it is 0.25 into v is 10 minus of minus. So you can take 10 minus of minus 10 by time is equals to 10 to the power minus 2. So 0.25 into 10 minus of minus 10 is equals to 20 into 10 square. This and this will again get cancelled. So 25 into 20 is equals to 500. 25 2s are 50. So you will get 500 Newton. This is your force value. Now, do you know you can get the solution for this question in one more method. Let us see what is that another method. So usually what we did is F is equals to ma, we did like that. So one more method is that even in the previous question you can use like that, but this is better. So in this question also we'll try to use that. Alternative, we can use the equation v is equals to u plus at. Okay. Here final velocity is 10. Initial velocity we have taken as minus 10. Acceleration did they give? No, they have not given. Time they have given? Yes, 10 to the power minus 2 seconds. So this minus 10 will come to the left hand side as plus 10. 10 plus 10 is equals to 20. And 20 by this also will come over here. 10 square is equals to acceleration. This 10 square will go upside as this 10 to the minus 2. This 10 to the power minus 2 will go upside as 2000. So the acceleration is equals to 2000 meter per second. Now F is equals to ma. Mass is equals to 0.25 into 2000. 2000 into 0.25. It is equals to 0.0005 is a 10, 0004. F is equals to 500 Newton. So either you do it in this method or you do it in this method. Both the methods are same. Both the methods are easy only. But here the thing is, you Just have to remember in these kind of questions, when it is going, it is negative. When it is coming back, it is positive. So what we did here is F is equals to ma, mass is 0.25 kg, v minus u, v we have taken 10 minus of minus 10, you will get 20 by 10 to the power minus 2, you cancel it, you get F is equals to 500. Alternative, you can use v is equals to u plus 80, you will get acceleration. F is equals to ma, mass is 0.25 into acceleration 2000, you get 500 Newton. Let us move on to the last question of this video. Let us see. So now we have our next question over here. A batsman deflects a ball at an angle 45 degree without changing its initial speed, that is 54 km per hour. If the mass of the ball is 0.15 kg, find the impulse imparted to the ball. This question is a little bit tricky and this is a little bit hard to understand, this kind of question. So here actually we have to use the logic of vectors. So if you visualize this thing, there is a ball from point O to point A. It is coming with velocity v1. Okay. From point O to A with velocity v1. Now the bat is hitting it and it is going like this from A to B with velocity v2. This angle over here is 54 degree. Sorry, 45 degree. So here it is not like we have to take v2 minus v1 because the initial and final speed is same. No, we should not take that. We have to find the change in a different method. Here from O to A, this is one velocity, this is another velocity. You have to find the resultant. From here, what is the resultant of the first vector and second vector? You have to find the resultant, and that resultant velocity will be v, and that v is the final, that v is the change in velocity. So actually this is even like, usually you will think that it is initial speed 54, then final also 54, 54 minus 54 0, then change in momentum 0, impulse 0. Is that possible? Impulse 0? Yes, it is possible. That first question we did impulse 0. But here if you are hitting a ball with the bat, then it requires some impulse, right? So here what we do is we are taking the resultant. So how we are taking the resultant, what we are doing over here, let us see. From O to A with V1, from A to B with V2 at an angle 45 degree, the resultant R. And will the resultant be like this? If you have read the vectors chapter or if you have seen the vector video, this resultant won't be correct because here the arrangement is actually like this. From tail to head, head to tail arrangement this is. So you can use one law, that is triangle law. Otherwise you can use the parallelogram law also over here. It will suit perfectly. From O to A like this, A to B like this. So you can just shift it over here like this, and this one you can shift it over here like this, and this will be the resultant. Now resultant, this is O, let us see, this is A, this is B, and this is 45 degree, this is the V, V1, V2. Now velocity is equals to 54 km per hour, which is equal to 54 into 5 by 18. 18 ones are 18 threes are, which is equals to 15 meter per second. So the velocity of the ball, this is equals to 15 meter per second. Now resultant R, resultant is here V. So V is equals to under root V1 square plus V2 square plus 2V1 V2 cos theta. Okay. This is the parallelogram law of vector addition. This comes under vector. So this V1 square. What is V1 square? V1 is 15 meter per second. 15 square, 225. It's a little bit tricky. 2V1 V2. 2 into this cos theta is equals to 45 degree. Better. So 2 into V1 V2, it is 15 to 15, 225. Cos 45 degrees 1 by root 2. Okay. You have to cancel this root 2. How will you cancel this root 2? 2 you can write as root 2 into root 2. Okay. So similarly you can write 3 as root 3 into root 3. x as root x into root x. That same we are going to use over here. 225 plus 225 plus root 2 into root 2 into 225 into 1 by root 2. Root 2 and root 2 gets cancelled. So finally this equation right here, this will become as v is equals to under root of 225 225 plus 225 plus 225 root 2. See, let me explain what I did here again. It is v1 square plus v2 square plus 2v1 v2 cos theta. This comes under vector parallelogram law of vector addition. v1 is 15, so 15 square plus 15 square plus 2 into 15 into 15 is 225. Cos 45 degrees 1 by root 2. This root 2 you have to eliminate. So that upper 2 you can write it as root 2 into root 2. That root 2 and this root 2 gets cancelled. So you will get 225 plus 225 plus 225 into root 2. Now root 2 value is equals to 1.41. So you can take 1.4. 225 into 1.4. So this 225 into root 2 under root 225 plus 225 450. So 450 plus this value is 315. Okay, I'll explain once again in the end if you're confused. This one will be 5, 6, 7 under root 765. What is this? This is the velocity. This is a change in velocity. See, this is initial, this is final. You want the change, right? You won't do v2 minus v1 over here. You just directly find the resultant. The resultant is the change in velocity only. You can see like that. So, root of 675. Now, 25 square is equal to 625. So, 27 square. Seven sevens are 49, balance 4, 14, 18, 2 sevens are 14, 2 are 4, 5, 9, 7, 29. So not 27. 27.5 also won't come. 27.7. If you multiply 27.7 into 27.7. Nine, 10, 11, 12, 765, 767. So 27.71 or 27.72. So you can take it as almost 27.7. You can take 27.7. Almost 27.7. So you got delta V or V is equals to 27.7. Now we have to find the impulse. I is equals to, see, here actually, let me explain this process till now. Actually what we used was, we used the parallelogram law of vector addition, that same formula, a square plus b square plus 2ab cos theta. That one we have used over here. A square is 15 square, which is 225, plus b square, that is b square again, 225 plus 2 into 225 into 1 by root 2 cos 45. That 2 we represented as root 2 into root 2. Root 2 and that root 2 be cancelled. So we got 225 plus 225 plus 225 root 2. Root 2 value is 1.4. We multiplied that with 1.4 and we got 315. Under root 450 plus 315 is equals to 765. Root 765 is equals to 27.7. Now this is actually delta V. Okay, so impulse is equals to mass into delta V. How we are saying this? Impulse momentum theorem. So mass is 0.15 kg. So 0.15 into delta V is 27.7. Calculation. 4.15, which you can almost take it as 4.2 kg meter per second. This is the value for impulse. The impulse is 4.2 kg meter per second. A batsman deflects a ball at an angle 45 degrees Celsius without changing its initial speed, that is 54 km per hour or 15 meter per second. If the mass of the ball is 0.15 kg, find the impulse. Impulse, we have to use that momentum. Impulse momentum theorem we have to use. Impulse is equal to change in momentum. Change in momentum is mass into change in velocity. Change in velocity we have to not find using this V2 minus V1. We have to find using that resultant. This is kind of confusing, but still we have to use the resultant. That is how the solution is actually for this question. Other method is you can use this initial, this one V1 and V2. You can actually say like this also. This V1 comes like this. This is V2. Okay, this is 45 degree. You can divide this into half. Then you can take this V1 cos theta, V1 sin theta. Horizontal you can divide separately. Horizontal you can substitute separately. Vertical you can resolve separately. Then you can add, or you can do it in this method. This method is way easier than that other method. So then we use that law and we got our delta V. Impulse is equals to mass into delta V. This is 0.15 to 22.7, and impulse is equals to almost equal to 4.2 kg meter per second. So I hope you have enjoyed today's video. In today's video we have completed every topic, not every topic, but we have completed most of the topics in impulse. Now there are some things like applications of impulse, that if a bullet, n number of bullets, so n mv square by t 2t, that these things are that applications of the impulses, that at a conveyor belt, so this much amount of dirt. We have even solved these kind of problems in Newton's laws of motion part 2. In that we have learned about this conveyor belt, and these applications now we won't be discussing. So I hope you have enjoyed today's video about impulse. I hope it was informative, and if you like this video, definitely like the video. Subscribe to this channel if you are new. See you next time in the next video. Thank you and goodbye.